Alright, Assalamualaikum warahmatullahi wabarakatuh. A very good morning, evening, night. I don't know, depends on the time you watch this video, I guess. My name is Afiq bin Herman, and I'm here today to present to you guys on the topic application of differentiation. So you must be wondering, what is differentiation, right? Differentiation is a fundamental concept in calculus that deals with finding the rate of change of a function. In simple terms, it helps us understand how one quantity changes with respect to another. This process of calculating the derivative of a function has many practical applications in a wide range of fields like physics, economics, engineering, biology, and more. In real-world situation, many phenomena depend on change and growth, whether it's an object moving, a business growing, or the population of a species. Differentiation allows us to model and analyze this change. So now let's go to the example. A farmer has 200 meters of fencing and wants to enclose a rectangular area of a garden. What dimension should the farmer use to maximize the area of the garden? So first of all, for this question, let x equals to length of the rectangle and y equals to width of the rectangle. So we get 2x plus 2y equals to 200, and then we can simplify the equation. So we get x plus y equals to 100. As we know, area of a rectangle is length times width, which is in our case will be x times y. Then the equation will be area equals to x times, and then y will be changed with 100 minus x. Then we get the answer 100x minus x squared. We can differentiate the answer, so the answer will be dA dx equals to 100 minus 2x. And then we set the derivative to equal to 0 to find the critical point. So 0 will be equal to 100 minus 2x, then x will be 50. To confirm that this is a maximum or minimum, we can check the answer using the second derivative. So then we use the second derivative and then we'll be getting negative 2. Then since the second derivative is a negative, the critical point corresponds to maximum. So then our conclusion will be the farmer should create a square garden with a side length of 50 meters to maximize the area, which will be 2,500 square meters. For the second example, a company manufactures a product and wants to minimize the cost of packaging. The product is cylindrical in shape and the company needs to design a can to hold the product. The can must hold 500 cubic centimeters of the product. What dimension of the can will minimize the material used for the surface area and thus minimize the packaging costs. To the solution, as we know, volume of cylinder is pi r square h, where r is radius and h is height. We already know the volume is 500, so then pi r square h equals to 500. Then we just get the h equals to 500 over pi r square. Then as we know, surface area of a cylinder is 2 pi r square plus 2 pi r h. Then we already get the h, so we put the h in our formula, so we get 2 pi r square plus 2 pi r 500 over pi r square. And then the final answer will be 2 pi r square plus 1000 over r. After differentiate the equation, we will get dA dr equals to 4 pi r minus 1000 over r square. And then we set the derivative equal to 0 to find the critical point. So then we get 0 equals to 4 pi r minus 1000 over r square. And then we simplify it to the point we get the r, which is r equals to 4.3. Using our r, we can find our h, which is we just use our r in our equation. So h equals to 500 over pi r square. Then we put our r in it, 4.3. So 500 over pi 4.3 square. So then we got 8.6. To confirm that this is a minimum or maximum point, we can just use our second derivative. So then we get 4 pi plus 2000 over r cubed. Then r will be get 4.3, which is a positive number, so that it confirms that the surface area is minimized at the value of r. To conclude, differentiation is essential to understanding the dynamic process in the world around us, whether it's tracking how fast an object moves, how a company profit change with the number of items sold, or how a population grows over time. Differentiation provides a mathematical tool needed to model and predict these changes. It provides insight into instantaneous rates of change and help identify critical points where insignificant change occur, such as peak, valleys, or inflection point. In summary, differentiation is more than just a mathematical technique. It's a tool used across disciplines to analyze and optimize various systems, helping to solve real-world problems that involve change. So, I think that's all from me. Thank you so much for watching this video. Bye-bye.